Hi everyone, this is Asis. I'm first year PhD student at NWI, National Wood Institute, Texas Tech University. And the topic that I'm presenting today is rural electrification using solar and wind energy in the Karnataka province of Nepal. So this is not what I do for my degree, but this topic I've done maybe a couple of years back while I was in undergrad. And this research not particularly explains or answer the research questions, but it will talk about the socio-techno-economical aspect of the distributed renewable energy and what impact it can create in the far-flung places like the rural places of Nepal. So my case study and my topic will be on the rural electrification of Karnataka province, one of the provinces of Nepal. And so the abstract is this is what I have said. It's about the rural electrifications, and we're talking about the Karnataka province. You can see on the top the province with the red portion. That's the Karnataka province, and it is one of the largest, but unfortunately most deprived in terms of electricity and infrastructure development. And this province, around 67% of the people in that province do not have access to electricity. And it's very misfortunate at this point of time where people, like more than 60% of the people do not have access to electricity. And the reason that people do not have access to electricity is because of the geographical terrain. There are a lot of mountains out there, and it is very, very difficult to extend the national grid. And government has not put much effort on doing that because the population is very diverse and you don't have many people living in one area. So it is not economically viable for a country like Nepal to extend the national grid to that region. So that's the one reason why people do not have access in that amount of quantity in terms of electricity. And what we have done is we identified the problem. We did the resource assessment of the region where there is no access to grid connection. And in Karnataka province, there are 10 districts and 5 districts do not have access to electricity. And we did the research assessment of those 5 districts. And out of that, we did a 2-case investigation, 200 kilowatt solar and 100 kilowatt wind in those regions. And we have chosen this size of the plant very small because the people living in small communities. So we have done the case study on that. And so as I've already said, the methodology starts with the problem identification. It's the problem that the people of that part of the world is facing. And the second thing we did is the resource assessment based on the data, meteorological data and the government data that we got. And third thing, we did the site selection based on the resource assessment, which place is best for what kind of renewable energy. And third thing is the 3E analysis. 3E analysis stands for energy, economic, and environmental analysis. So we've done this for both the plant, and we have discussed and put out some suggestions what can be and how this distributed renewable energy can do. And as I've already said, the image that you're seeing is one of the place of the province that's near to the China border. So this place also do not have access to electricity. So there are a lot of small communities living in there. Around 67% of the people do not have access to electricity. And if we compare all the 7 provinces of Nepal, the Karnataka province in the red line, you can see the road density is also very less out of 100 kilometers square, and the electrification you can see is 27%. And the other province is comparatively better than what the Karnataka province have. And so that's the problem that we have seen. And if you can see here, the current electricity access in Nepal. I'm not sure if you can see all the percentages in that figure, but from the table, what we can see is the fully electrified municipalities in Karnataka province is none. So none of the municipalities in that province do not have, they have access to electricity, do not have access. So that's what this scenario is, and that's what our case study will be in. So as I already said, second thing we did is the resource assessment of the 5 districts. You can see, so the 5 districts are those with the gray color. So those 5 districts we have done the research assessment for that, and these data we got it from the meteorological towers and also from the government So we did the how's the slope in that area, temperature, wind, solar irradiation, population distribution. The solar irradiation is quite good in that region, but the wind is not very substantial, and we have discussed that in our further slides. And so the third thing we did was the case study based on the research assessment. So for 200 kilowatt solar plant, we chose the Mugu district. That's on the upper side, Mugu. So that where we get the maximum solar irradiance of around 1901 kilowatt hour per meter square per month. So the image that you're seeing is the capital of that district, Khamgadi. So we have looked the feasibility of 200 kilowatt solar plant in that area. And the people living in there is around 55,000 people, and around 60% of the people have access to electricity by because of the micro hydro they have, but 40% of the people do not have access. And that 60% is also very fluctuating because only in the summer, because it's a runoff river type micro hydro, so only in the summer, only in the when there's a raining, there is a power. So that's the situation. And for this, we did the energy evaluation. The energy evaluation says that for 200 kilowatt solar plant, we have around 383.2 megawatt hour of energy coming out. And if we see the loss diagram, it's very interesting to see that the PV loss due to temperature is about 1.96%. So what does this say is we have also investigated for a reason where the temperature is high, and where we found that PV loss due to temperature is more than 15%. So this helps us to understand that PV installation in this part of the world where the temperature is very moderate, for PV cell to perform efficiently, it needs around 20 to 25 degrees Celsius, and we have a best fit for this kind of installation in this part of the world. And we have chosen all this PV type, inverter type based on the availability in that region. And for the economic analysis, we got around 0.04 per USD per kilowatt hour, and this is very comparable with US. And the reason is the border is very near to China, so all the goods we get at the cheap rate than what we get here. So that's the one reason the price is comparable with the US, although because of all the geographical difficulties and everything. So if we sell the electricity at the same rate what government sells, the payback period is around 8.5, and it's all about the economic thing. And the environment thing also, we are balancing CO2 around 330 ton every year. So that's what the solar case study is about. And for 100 kilowatt wind energy, we also chose this location based on the resource assessment, and it's on the Tila village. You can see up there. So it's on the right. That's a community where the people reside, and the river that you're seeing is Karnali, where the name of the province comes from. And so people living here are around 13,000, and they don't have access to electricity as well. And the graph you're seeing is the overall Nepal, this mean simulated wind speed. So that's for all the Nepal, and we have also collected 5 years data for that location from 2015 to 2019, and we can see that the wind speed is not very substantial. This speed is recorded at around 10 meter height, and so that's how the wind power plant and wind energy is all about in that region. And we based on the data we get, so we also got the energy density and power density and all these values in the table, and we also see the frequency of what will be the frequency of the wind available in that region. And the LCOE for this is a little expensive than here because of the wind resource quality. We don't have very good wind quality over there. However, if we try to install for a small scale wind turbine, maybe at 30 meter height or 50 meter height, we can get substantial electricity to electrify that region. So that's what we did basically. And if we see the World Bank statistics, the electric power generation consumption kilowatt per hour per capita of Nepal is 146 kilowatt hour, and that's very less. So with this figure, we can say that with 7 to 10 megawatt hour energy plant, we can provide electricity to 300,000 people living in that part where there is no electricity or grid connection. And we cannot make a single plant of 7 to 10 megawatt hour in that region because the population is distributed. So for this reason, for this kind of reason, renewable energy, distributed renewable energy can be very important to electrify those regions. And the basic, we have done the basic calculation, and it says that like most of the places feasible for the installation is solar. So if we install around 20 solars and the 10 wind plant, based on the research estimate, the total cost will be roughly around 9 million. That's very not very rigorously studied, just to provide the glance of it. So the conclusion says that the distributed energy is very significant in that region. Instead of extending the national grid, in spite of all the complications and for the diverse population, the distributed universe can be very, very significant. So that's what it's all about. So this is one of the figure. That's the near of the Mount Everest, nearest village, nearest town before when you try to summit for the Everest. That's in Nepal too, but that's little east to the Karnataka province. So yeah, there it is. Thank you very much.